All right, guys, we're starting our second to last unit of the year. And before we get started today into the calculus, let's explore a couple geometry and algebra ideas that will lead us into hopefully a clear understanding of why we're doing what we're doing and how it works. So start by trying to find what's the area between this semicircle and this line. So what is this area here, this shaded area? And hopefully you were able to find it by using an idea that, like, okay, well, if this whole thing was shaded in, if all of this was shaded in, we would be able to find that easily. If this whole thing was shaded in, it would just be the area of this rectangle. And the area of the rectangle is length times width. And so the height of this rectangle is 2, and the width is 1, 2, 3, 4. And so the area of the rectangle, this is the rectangle's area, is 8. But it's missing the semicircle. And so what we can do is we can take away the semicircle to find what's left over in this part of the rectangle that's missing. So, so the area of a semicircle is pi r squared divided by 2 because it's only half of a circle. So pi r squared would be a circle. And the radius of this circle from the center to the outside, this distance is 2, or 2 here. And so this is pi times 2 squared divided by 2. So 4 pi divided by 2 is 2 pi. So 8 minus 2 pi is the best way to write this. We could write negative 2 pi plus 8 as well. That would be fine. But this is this area. So we can find the area of a shaded in part sometimes by subtracting the missing area from a shaded in spot. Okay, so with that in mind, let's move on to an algebra thing. Let's make sure you can graph both negative y equals negative x squared plus 5 and y equals x plus 3. So go ahead and try to do that. And hopefully you know that these are the points that are on y equals negative x squared plus 5. It's the quadratic parent function usually looks like this. It's shifted up by 5, so there's a vertex at 0, 5, and it's negative, so it's going to have the points here. So 1 squared is 1, so those go here. 1, 2 squared is 4, but it's going to be 4 down. If we were to make one more point, we could go 3 over, and 3 squared, 3 times 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that'll be the same here. So here's our quadratic, looks like this. And we also want to graph y equals x plus 3, so what points does that have? Well, it's got a y-intercept at 0, 3, and it's got a slope of 1. This is 1x, so up by 1, over by 1, up by 1, over by 1, up by 1, over by 1. Looks like this. So this is the graph of y equals x plus 3. So now the question is, what is the area bounded by these two graphs? And bounded by means like these form the boundary of it. So, what part is, I guess we could say enclosed by would also be like a similar phrasing. This, I hope we can see, this is the area that is bounded by them. These make a boundary that completely encloses those two things. Now, how on earth could we get this area? Think about it for a second. I'm not going to take off points if you missed this one, but I hope you're able to think about it a little bit. The area, we can do it using the same idea from over here, which is we can use integrals to find the area of this whole thing. Remember, so this red area that I'm putting right here, this would be the integral from negative 2 to 1 of the quadratic, because remember the integral will tell, so of negative x squared plus 5, the integral tells you the area under a curve bounded from an x to an x and in between the x-axis. So that's this part. But that's not exactly what our area is. It's missing this part right here, right? And so just like before, we're going to subtract, and here we can do the integral from negative 2 to 1 of this line. This is x plus 3. Or you could just find the area. This is a trapezoid, so we could do like the base. I'm going to actually do this rather than like doing the antiderivative. Well, let's do the antiderivative here. This is negative 1/3 x cubed plus 5x from negative 2 to 1. So that's the area of this whole red one. Minus here, instead of doing an antiderivative and doing the area that way, I'm just going to treat this as a trapezoid. So we've got two bases that are parallel. This one has a height of 1. This one has a height of 4. So 1 plus 4 divided by 2 times the height from negative 2 to 1. That's 3. So times 3. Okay, so let's plug this in. Negative 1/3 x. Oh, sorry, negative 1/3. We're just going to plug in 1 plus 5 minus, when we plug in negative 2, we'll get negative 8, which will be positive 8/3. Negative 2 here will be negative 10. And let's see if we can combine these. This is 15 plus 7/3, I believe. So negative 1/3 plus 8/3. Combining these is 7/3. 5 minus negative 10 is 5 plus 10. That's where the 15 came from. And then we also still have this from over here. So plus minus 15 halves. So 1 plus 4 is 5. 5 times 3 is 15. And this is like super ugly. I guess I got to get into sixths, right, to make it a common denominator. So I've got 96 because I multiplied by 6 over 6. Here I have to multiply by 2 over 2. 14/6 minus 45/6. And so this is 104 minus 45. I don't know why I waited until the end there to break out a calculator, but I did. Oh no, my battery is low. 90 plus 14 minus 45. So this is 59/6, or it's also fine to say 9.833 in this class. We can round to 3 decimal places, but this is best. So the big idea here is we learned earlier in the year how to use integrals to find the area of functions, underneath functions, between the x-axis. Well, we can find the area between two curves by finding the integral of that whole area and then taking away the area below, which is another integral. So an integral minus an integral can do it. So let's move on to our notes today. And this is our second to last unit of the year. We're going to be dealing with areas and volumes. And so the area of a region between two curves, if f and g are continuous, and let's say that f is above g, let's say greater than or equal to g. So you've got some picture where there's a function f that is above another function g, okay, for all x between a and b. Then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b. So this is bounded by, right? So it's enclosed by x equals a, x equals b, f on top and g below is, well, it's always going to be, go ahead and see if you can figure out which one of these it would be. So it's going to be this full area, right? Like the area under f is the integral from a to b of f, that's like all of this, okay, minus, we want to get rid of this area that's underneath g so that we have the area that's only in between them. And so what we'll do is we'll say minus the integral from a to b of g. And our properties of integrals say that we can actually combine this into a single thing. So usually we'll write this as f minus g, like this. So that's it. That's what we do. We do the top one minus the bottom one. It's just the integral of the top one minus the bottom one is the area between two curves, which is going to be super useful. That is the big idea for today, and now we're just going to be practicing it. So we want to find the area of the region bounded by the graphs of x squared plus 2, negative x, 0, and 1. So I think it's worth drawing it first. Here's x equals 0. Here's x equals 1. X squared plus 2 is a quadratic, so 1 squared is 1, 2 squared is 4, it'll be way up here, kind of looks like this, and negative x, which looks like this, has a y-intercept of 0 and a slope of negative 1, and we're looking for the area bounded by x equals 0, x equals 1, and these two curves, so we're talking about this area right here. And the formula says we're just going to do the integral of the top one minus the bottom one. So this is the integral of x squared plus 2 minus negative x. So this is f minus g. And this is the integral from 0 to 1. That's where x goes from. So this should make a lot of sense, guys. We're doing like the top one minus the bottom one. That's the area between them. Okay, so let's do the antiderivative. This is plus x, so this is plus 1/2 x squared from 0 to 1. So we get 1/3 plus 2, I'm plugging in 1, plus 1/2 minus, when we plug in 0, this is all 0. So 2 plus 1/3 plus 1/2. I need to change it to sixths again. I guess we're doing a lot of sixths today. Sixths. This is going to be 12 sixths multiplied by 6 over 6. And this we have to multiply by 3 over 3, 3 sixths. So this is 17 sixths. Or, you know, again, it's okay to have it. Man, my battery's about to run out. I hope it doesn't run out. I have another calculator here. It's 2.833 is also acceptable. 17 sixths is usually considered the best answer, but this is okay too. Switch on my calculator. This doesn't kill me later because we're gonna need a calculator today, guys. We are. You're gonna need a calculator later. Okay, try this on your own. So hopefully we understand it's the area of the top minus the bottom. Find the area of the regions bounded by the graphs of f of, and feel free to use a calculator for arithmetic, guys. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. So, you know, again, we can graph it. Here has a y-intercept of 2. It's a quadratic, so 2 over, 1, 2, 3, 4 down. 2 over, 2 squared is 4, 1, 2, 3, 4 down. We know it's going down because of this negative in front of x squared. And then y equals x has a slope of 1 and a y-intercept of 0. And we want to find the area bounded by these graphs. So we're talking about this area right here. So hopefully you realize it's the area of the top one minus the bottom one. So it's going to be 2 minus x squared minus x from x equals -2 to 1. So from -2 to 1. So we go from where they intersect. So we do have to find where they intersect. So this is going to be, we do the antiderivative. This is 2x minus 1/3 x cubed minus 1/2 x squared from -2 to 1. We plug in 1, 2 minus 1/3 minus 1/2 minus, okay, we got to plug in -2 here. It's -4 plus 8/3, because -2 times -2 times -2 is -8 times the negative is positive. And then -2 squared is 4. 4 divided by 2 is 2, minus 2. Boy, this is really ugly. Okay, so 2 minus 1/3 minus 1/2. This is minus 6 minus -6 is plus 6 plus 8/3. Let's combine some things. 2 plus 6 is 8. -1/3 plus 8/3 is 7/3. And again, I'm going to have to get this in 6. I'm just going to use a calculator here to put this in decimal. I believe it's going to be the exact same thing as what we had in our warm-up, actually. But let's do it. 8 plus 7/3 minus 1/2. 9, but yeah, that is what we had. So this is, I believe what we got there was 59 sixths. We press math fraction to get into a fraction if we want. 59/6, which is 9.833 to 3 decimal places. Okay. Now, I want to talk to you real quick. What if we didn't have this graph here? How do we know what to do the integral from? Well, what we're always going to, didn't tell us the integral. What we're going to look for a lot is the intersection points. Where do they hit each other? And the way to find where they hit each other is where they're equal to each other. So where is f of x equal to g of x? And we could do this without this graph, which a lot of times we're going to have to do. So we'll set 2 minus x squared equal to x to see where they intersect. I'm going to make this equal to 0. Since the x squared is negative, I'm going to move it to the other side. And this is a quadratic we solve by factoring. That's why I'm making it equal to 0. So this is x plus 2 times x minus 1. These multiply to make -2, but add to be 1. So x equals -2 and x equals 1, which is where they intersected, right? So that's the intersections. Here we don't have a graph, guys. First, we want to find the area of the region between these two graphs. So go ahead and start by finding where they intersect. Where do these graphs intersect? And hopefully you did it by, setting them equal to each other. For polynomials with degree greater than 0, we want to make it equal to 0, so we're going to add x squared to the other side. We're going to subtract 2x. 3x cubed, this cancels out, that's nice. And we can factor out a common factor of 3x. So 3x times x squared minus 4. Ooh, this is really nice. So 3x times x minus 2 times x plus 2. And so x equals 0, x equals 2, x equals negative 2. This intersects at multiple places. So let's see, we've got a cubic, some sort of cubic with a thing here. It's going to look like this, right? I don't know. And we've got a quadratic, a negative 1, I don't know. It's probably going to look like this, whatever. This is probably how it's going to look if I had to guess, but we can graph it to confirm. You'll notice they intersect at x equals negative 2, at x equals 0, and at x equals 2. And so there's two different regions here. Two different regions. Now we have to be a little bit careful because our formula at the top always said we could do it if it's the top one minus the bottom, right? The top one minus the bottom one. Well, here it switches which one is the top one. The cubic one, this is F, this is G. The cubic one is on top here, but now it's on the bottom, right? The quadratic one is on the bottom here, and now it's on top. And so you have to actually split this up into two different integrals. So this is going to be the integral from negative 2 to 0 of the top one, which is f, minus the bottom one, plus now we have to do the integral from 0 to 2 of the other way around because now g is on top. Okay? So we can do that. I think this is a great time to talk about how to do this on a calculator because this often comes up on the calculators. We could do this without a calculator. I mean, we could do this and, go ahead and do the antiderivatives and it would come out fine. But real quick, guys, make sure you have a calculator. If you don't, grab one off of the front page of our blend course. And what we almost always want to do is we want to go into y equals. So we go to y equals, and we're going to put in whatever functions we have. It's usually just two functions. So 3x cubed minus x squared minus 10x. And the other one is negative x squared plus 2x. And let's see some calculator skills. We need to be able to find where they intersect. So, okay, I'm going to press zoom 6 to get us back to like the normal zoom. I want to make, if you guys don't know, you can make the x res equal to 2 and it'll graph twice as fast. So that's nice sometimes. Okay, so here we can see it is like basically what I graphed over here, although stretched slightly differently. We can find the intersection by pressing, so this is something you might want to write down if you don't already know it well. You press second calc, so second calc right here. And we need to be able to find the intersection. This is a calculator skill you have to find. Okay, so obviously one of the intersections is 0, 0. You can do it again, second calc intersect. So second calc intersect. But before you press enter 3 times, you need to press enter twice. And when it says guess, you see how here at the bottom left it says guess? You need to move the guess to the closest intersection you want. It always finds whichever one is closest. And so we have to press enter after we move it. So it's like enter times 2, and then move your guess to the right place, and then enter again. And so now we can see the other intersection is negative 2, and our last intersection, and we would be writing this down if we hadn't already written this down. Like we already solved for this. So the guess needs to be close to here. And the other one is 2, 0. So we find our intersections. And now what we're going to do is we can literally, like in the main screen, do integrals. So the way you can do an integral is by going to math. So you press math. This is how you do an integral, math. This is worth writing down. Fn int, it says Fn int. That's the integral button. So Fn int of, so we have two different integrals. We said it was going to be negative 2 to 0 of the cubic one of f Now, guys, instead of doing like retyping this in and saying like this all typed into the calculator screen again, there's an important thing you want to know. So, oh, sorry, I should have pressed math 9 for integrals. Okay, let's make sure we know that. And now to do y1 minus y2, we already put these in y equals to find the intersection. We're almost always going to like find the intersection, so you have to put it in y1 and y2. You don't need to retype it. Instead, what you do is you go to variables. There's a variables button right here. So you go to variables, vars. Oops, what did I press? I pressed enter or something. Okay, I meant to press variables, variables. And then you press over to y vars, y variables, and press enter. It'll on function. And now you can do y1. Like this is the same as typing 3x cubed minus, it's the same as typing 3x cubed minus x squared minus 10x, because that's what y1 is. y1 is that. So we type y1, then we put minus variables. We go to y variables, enter, and we choose y2 now, y1 minus y2, dx. And we're going to do the second integral, right? We can do the second integral at the same time. We said it was going to be negative 2 to 0 of f minus g, plus, we end it with a dx, plus math 9, 0 to 2 of, now we have to do y2 minus y1, because our y2 is g of x. So we're going to do that. We're going to press oh man, I wish I hadn't pressed quit. So we're going to go to variables, y variables, enter, y2 minus y1. And guys, this comes up on the reason you really want to learn about this is it's going to get a little bit more tricky, and it's really important to like, it's so easy to mess up when you have a bunch of parentheses and pies, which you're going to see coming up in a few lessons. But if you just put y1 minus y2, you're not going to mess it up. So there we go, 24. That's the area between them. It just does the integral. It's really nice. All right, guys, let's see how you guys do on this. This is a calculator problem. You need a calculator. Here is R, this region. It's the shaded region in the first quadrant enclosed by y equals e to the negative x squared and y equals 1 minus cosine of x, the y-axis, as shown in the figure. Find the area of R. So the major mistake, if you got this wrong, go to 3 decimal places. The major mistake if you got this wrong is most people say the integral from 0, and then some people put 1 here because it looks like it's 1. You cannot assume that. You can assume this is 0 because it said it was the y-axis. But this, you needed to find the intersection between these two curves. You have to. So you put these into y1 and y2. Y equals, so y1 is going to be e to the negative x squared. I'm going to put f of x here just to remind me that that's my first one. And y2 is going to be 1 minus cosine of x. I'm going to call that g of x. And so I've got the intersection. I need to graph them. I'm going to zoom in a little bit. I'm going to make my window go from whatever it says here. So my window is going to go from just a little bit below negative, before 0, like negative 0.5. My window I'm setting to be the window that's here, negative 0.5 to maybe 1.5. And the y-min is going to go from a little bit below 0, like negative 0.5 to 1.5. So that way I can kind of see what we're seeing here. We can kind of see the same thing, right? And we're finding the intersection. Second, calc, intersect, enter, enter, enter. There it is. That intersection is not at x equals 1. The intersection, and it's worth writing this down, guys. This comes up in the free response problems a lot. So intersection x equals 0.942. We can round to 3 decimal places here if we want. So 0.942. All right, so we're doing the integral not from 0 to 1, but from 0 to 0.92 of, let's do it. Let's press math 9, the intersection from 0 to 0.942 of variables. Oops. Yikes. Variables, y variables, function y1 minus variables. I'm pressing this variables button here. Y variables, y2 dx. And guys, if it ever comes out negative, like let's say you mess it up, if you accidentally put like the wrong one, so let's do the exact same thing, but like what if we put y2 minus y1 accidentally, like we forgot which one was on top. If you ever like get the wrong one on top, it'll come out exactly the same. It'll come out exactly the same but negative, so you can just be like, oh, I switched it. You could just be like, oh, I'm gonna like switch it around. If you like, whatever. So like if you aren't sure which one's on top and if it comes out negative, well, switch it around because it was the other one that was on top. So there it is. So the answer is, so this was of e to the negative x squared minus, we need to put this in parentheses, 1 minus cosine of x dx, and this is equal to 0.591. Okay, great. This is a no calculator one. The area of the region in the first quadrant that is enclosed by the graphs of y equals x squared plus 8 and x plus 8 is, so you want to like kind of graph this to yourself in your head. So here's x cubed plus 8, it's like a cubic, and x plus 8 is linear. And it says the area enclosed by them in the first quadrant. So there's also some more area over here that's enclosed by it, but it said only in the first quadrant. So this is quadrant 1 right here. So what integral? Well, we need to find where they intersect. Obviously, they intersect at 0, 8, because they both have a y-intercept of 8. But there's going to be another intersection over here. So we need to set them equal to each other. And what is that intersection point? Well, let's see. We subtract x cubed minus x, and the 8's will cancel out, equals 0. X times x squared minus 1 equals 0. You guys couldn't see that, I'm sorry. This is a difference of two squares, x minus 1 times x plus 1. And so we can see that x equals 0, x equals 1, and x equals negative 1 are their intersections. But we only care about 0 and 1. This is what we're doing. So it's the integral from 0 to 1 of the top one minus the bottom one. The top one is x plus 8. And I know that just based on the shape of the curves. But if you didn't, again, if it comes out negative, you just like make it be the positive one because it'll switch it around. So the top one minus the bottom one, make sure you put it in parentheses. We want to subtract that whole bottom one. And so this is the integral of, let's simplify a little bit, x minus x cubed, and 8 minus 8 cancels out. So this is 1/2 x squared minus 1/4 x to the 4th from 0 to 1. When we plug in 1, we get 1/2 minus 1/4, and a half minus a fourth, this is 2/4 is 1/4. When we plug in 0, we get 0 for both of these. So I didn't write that. So 1/4. All right, the area, this is another this would be a no calculator one. The area of the region between 4x squared plus 2 and the x-axis from 1 to 2. So, okay, 4x cubed plus 2. And the x-axis, so I'm a little nervous, like, so is this always going to be above? It will. So from 1 to 2, this is the area between two curves, but if one of the curves is the x-axis, this is just minus, you can think of it as minus 0, or what we were doing in a previous unit, where it's just the integral from 1 to 2 of this curve. It's literally asking for the area between the x-axis, this curve, and that's the definition of the integral. That's like what our area definition of the integral is, of 4x cubed plus 2. So this is like an old thing from before. It's just the area under this curve. But you could think of it as minus 0 if you wanted, because this is y equals 0. So let's do the antiderivative. This is x to the 4th. We divide by 4, so it's just 1. This is 2x, and it's going from 1 to 2. So 2 to the 4th power is 16. 2 times 2 is 4, minus, plugging in 1, we get 1 plus 2. So plugging in 1 and 1 here. So 20 minus 3 is 17. All right, last one. The area of the region enclosed by y equals x and y equals x squared minus 3x plus 3. Okay, so I know y equals x looks like this. This is some sort of quadratic, but I don't know exactly like where it is. Let's find the intersection points by setting them equal to each other. So x squared minus 3x plus 3 is equal to x. Let's find what x's make that true. Subtract x to make it equal to 0 because it's a quadratic. Quadratics we make equal to 0, and then we factor. So we need to multiply to make 3 and add to be -4. So -3 and -1. Multiply to make +3 and add to be -4. So x equals 3, x equals 1. So I guess my graph isn't quite right? Like it must look like this. I guess that makes sense. The y-intercept's 3. So from 1 to, man, it's so bad. Hold on. Okay, looks something like this. So this is 3. So from 1 to 3. And the top one is going to be y equals x. But again, if you got it wrong, which one's the top one, it's not a big deal. Your answer will just come out negative from the exact right answer. So if you did this one minus this one, because you didn't know which one was on top, you just get up the negative of the right answer. But I know x is on top, just based on like my understanding of how to graph things from Algebra 1. So this is the integral from 1 to 3, because that's the intersection points, of x minus x squared minus 3x plus 3. And I'm always going to simplify this before I do the integral because it's fewer terms. So this is going to be negative x squared. X minus -3x is plus 4x. And minus 3 is minus 3. So I can combine this x with this minus 3x. And it makes it a little bit shorter because there's fewer things to do the antiderivative of. So minus 1/3 x cubed. Plus, this is going to be x squared. We divide by 2, so 2. And then minus 3x from 1 to 3. Oh my gosh, I ran out of room. This is so terrible. Okay, let's plug it in up here. So negative 1/3 times 3 cubed is 27. Plus 2 times 3 squared, which is 9. Minus 3 times 3. Minus, when we plug in 1, we get negative 1/3 plus 2 minus 3. So this is negative 9 plus 18 minus 9. Oh, that's all 0. Negative 9 plus negative 9 is negative 18 plus 18 is 0. Okay, cool. And then this will be minus a negative is plus 1/3 minus 2 minus the 2 plus the 3. So that make sure you distribute that negative. And so this is 1 plus 1/3. 1 is 3/3 plus 1/3 is 4/3. And again, if you had done the wrong order, if you had done like this one minus this one, no big deal. You would have just come out with negative 4/3 is the answer, and you'd be like, oh, well, I guess I chose the wrong one, was on top, and you put this one. Guys, I hope you're feeling pretty good about this. Again, the big idea is we can find the area between two curves by just doing the integral of the top one minus the bottom one. You can do it as two separate integrals, but we usually just combine them into a single integral. And in a calculator, you need to be able to know how to put in things into y equals. You need to know how to find the intersection by pressing second calc intersect. And you need to know how to then do the integral. And you really math by pressing math. So math and then 9 to get down to fn int. Oops. And you really want to be able to use the variables button to like be able to do just like f minus g. It makes it a lot easier. All right, guys, have a good rest of your day. I think by the time you get done practicing your homework on this, you'll feel pretty good about it.